Good evening. We're going to go on a journey to Mars. Now, Mars is a world in some ways fairly similar to the Earth and always been of special interest, mainly, I think, because of the chance of finding life there. So, is there any life on Mars? We're still not sure. We're trying to find out. But meanwhile, just for a moment, cast your mind back to the 1950s. Science fiction enthusiasts had great fun with Mars then. Do you remember Quatermass?
You know, Rennie, when I was a boy, it was the great burning topic, were there really canals there and who made them? I remember my disappointment when somebody proved that Martians couldn't exist.
It's a funny word. Worn out before anything turned up to claim it. Martian.
Welcome now, Dr. Chris Lintott. Chris, I enjoy Quatermass immensely. Well, I know you didn't see it in the original, but you've seen it since. What do you think?
It's fantastic, isn't it? This vision of Mars as the place from which aliens come, which is right through 20th century sci-fi. Even though we knew that there weren't aliens on Mars, we'd come a long way from the 19th century view. Back then, observers with some quite large telescopes were drawing elaborate canal structures on the planet, believing these were the products of technologically advanced civilizations.
Pure trick to the eye. But of course there are dark patches on Mars, once thought to be seas, and then thought to be tracts of low-type vegetation. But of course you've got to remember, on Mars the air is very thin indeed, what we normally call a vacuum, and it's also dry, and there's no water. There's ice, but no water.
So the question going into the space age was whether vegetation could survive on Mars. And I know the sky at night demonstrated pretty quickly what would happen if you tried to plant things there.
We did. We took two cacti. One we kept under Earth conditions, and the other we subjected to what we thought were Martian conditions. And this is what happened.
Well, it's rather unlikely, I think, that any of our higher terrestrial plants would survive under Martian conditions, although it's just possible that some very lowly forms, which we've not yet tested, may. But just to show you the fate of higher plants, I brought along tonight two cacti. This cactus has been quite healthily growing under Earth conditions, and you see it's quite a nice, firm-looking sort of cactus. This one here has spent one night under Martian conditions, and I think you can see without any doubt that it's got a distinctly morning-after appearance.
Well, despite the lack of aliens, it's become very clear that Mars is a fascinating world. But of course, it never comes much closer than 35 million miles, so we were bound to be limited. The best way was to use space probes, and the first space probe went up in the early 1960s, both Russian and American. But the first real success came with America's Mariner 4 in 1965.
Yes, and like all the early probes, this just gave us a fleeting glimpse of Mars as it shot past. It's much easier to do a flyby of the planet than it is to slow down and go into orbit. So the early probes just shot past and sent back what they could. And Mariner 4 saw some amazing things nonetheless. For example, it showed us the first real images of craters on the surface of Mars, something you couldn't see from Earth.
And then came those marvellous pictures from Mariner 6.
We've just had some amazing photographs sent back by the American probe to Mars, Mariner 6. Mariner 7, by the way, has been brought back under control, and we await news from that. But meanwhile, we have this superb series of close-ups from Mariner 6, and I'd like to show you those pictures now, beginning with Mars, as seen by Mariner, from a distance of more than 700,000 miles, which, of course, is a great deal further than the Moon is from the Earth. And even so, you can see there some of the dark areas, which may be vegetation, and at the bottom you can see the white polar cap, which has always been thought to be due to some kind of icy or frosty deposit. And just look at that. Craters on Mars very similar to those of the Moon. And the largest crater on that picture is about 160 miles across. And remember, when Mariner took that picture, it was only about as far from the surface of Mars as we are from Moscow. And I wonder how those craters got there. What are they? Are they due to things hitting Mars, or are they volcanic? I believe myself that most of them are likely to be volcanic, but I remain to be proved wrong. And let me show you now the most spectacular of all these pictures sent back so far by Mariner 6. And just look at that. It's a crater 24 miles in diameter, seen from 2,000 miles. And just to give you an idea of scale, the area covered in that picture is about 63 miles by 48 miles. And I think you'll agree that that crater on Mars is very similar to a crater on the Moon.
Well, they may not look much compared to what we have now, but those images are stunning. It must have been wonderful to see such detail on a planet that's so frustrating through the telescope. It teases you with detail, but you never see anything like this, and then suddenly you had Mars laid out for you.
Yes, but don't forget, by sheer bad luck, the first mariners went over Mars in what we now know are the least interesting parts. And for a time I thought Mars might be rather a flat or dull kind of world. Well, it's not. Mariner 9 showed that.
But it had problems on the way in, of course. Mariner 9 was supposed to go into orbit around Mars. It did, but it found a dust storm waiting for it.
Now, although the Martian atmosphere is so thin, it evidently can produce dust. And we've seen dust storms before. And in fact, I, for one, was prepared for this because for some weeks now, I've been watching it from my observatory way down in Selsey in Sussex. And I've got 3 drawings here which will show, I think, more or less what I mean. In September, before the dust storm started, with my telescope, I could see a great deal on Mars, and here's one of the drawings I made then. And this shows the southern polar cap at the top. It shows that rather V-shaped marking, which we know as the Syrtis Major. One of those markings we always thought to be due to vegetation, although we're not so sure now. And above the Syrtis Major, you can see a rather featureless area, which we call Hellas. And then, in October, the dust storm started. And there's a drawing that I made on October the 4th. And this time, as you can see, the polar cap is very difficult to see, and the other features are very much less clear. And then the dust storm developed, and this last drawing was made this month, on November the 1st, and there again, in the middle, you can see the V-shaped Syrtis Major, but now you can only see a trace of it, and the entire southern part of the planet appears to be hidden by these swirling clouds of dust. And that is why, so far, we haven't had these spectacular pictures from Mariner 9 that we'd hoped we would, although undoubtedly they will come as soon as the dust clears.
Global dust storms, like that encountered by Mariner, are relatively common on Mars, but they certainly puzzled the sky at night back in 1971.
When you're talking about a planet like Mars, where the atmosphere is so extremely thin and approximating to what we normally call a vacuum, just how can it hold particles in suspension? And how could those particles be whipped up? Arthur, over to you. I know you've got some ideas on this.
I've got a little demonstration here, Patrick. This is a magnetic stirrer, and in this little beaker on the top, I'll put some very fine silica dust. Mm-hmm. And if I then switch on the stirrer, which rotates the little bar magnet, I think you can see there that there is a considerable cloud of dust rising.
It certainly is.
Now, of course, this means that we've got here the thick atmosphere of the Earth. This doesn't apply on Mars, and what puzzles me is how on Earth the Martian atmosphere manages to sustain a dust cloud. And so, for this demonstration, I brought along a chunk of Martian atmosphere, yes. Which is inside this desiccator, which has been evacuated to its 100th, Gilbert, isn't it?
Less than a 100th.
Of atmospheric pressure. And if I can get this magnetic stirrer to rotate again in here, there it goes, we can see that there isn't any dust coming up at all from this, you see, because the atmosphere is not thick enough to sustain it. And now, to try and show that we're not really cheating, I'll open this little cock on the top and let air in. I have to do this very gently.
There we go.
Oh, yes, you see what happens.
Well, that seems to be an experiment to prove that there can't be dust clouds on Mars.
I don't understand it, Patrick. It may simply mean that the dust particles on Mars are very much finer than anything we have.
Well, it was a good experiment, but we now know we got the atmosphere of Mars all wrong.
Yes, the composition's different from what you would have guessed then. The dust is different too. It's much smaller and finer grained than you would otherwise have expected, and that makes it easier to get up into the atmosphere. And these days we're used to dust storms, but we also see things like dust devils whipping across the Martian surface.
And the winds are quite strong there, although not very much force, because the air is so thin. Barometric pressure below 10 millibars everywhere.
That's right, but still there's quite evolved, quite dynamic weather system. In fact, weather on Mars has become a whole research topic on its own. But never mind the atmosphere. Yes. What Mariner 9 really showed us were the glories of the planet. For example, Olympus Mons.
Olympus Mons, a volcano taller than our Mount Everest, much taller, and formerly seen as Nix Olympica, the Olympic snow. We didn't know what it was.
But how can you not have realised it was a mountain? I mean, this thing's taller than Everest. How can you not have seen that from Earth?
We simply couldn't see it clearly enough. It merely appeared as a patch. It might have been a lake or snow, and we simply didn't know. It took Mariner 9 to tell us.
And here it is. Very interesting indeed. You can see there the crater-like structure, and you can see that it's got rather scalloped edges, and it is rather obviously a volcanic caldera. Here's another view of the Nix Olympica, and you can see there a very considerable amount of detail. And it looks very much like a volcano of the Hawaiian type, only the base is about 300 miles wide, which means that it's even bigger than Hawaii. So Mars does seem to have been a world where volcanism has played a very, very important part.
Well, much as you'd like to have visited Olympus Mons, that's a little difficult even for the sky at night. But you did do the next best thing, visiting Mount Teide in the Canary Islands back in 1973. And I have to say, it looks pretty Martian to me.
Now, how do you think Teide matches up with a Martian caldera?
I think very exactly. One looks, for example, at the beautiful pictures taken by Mariner 9 looking straight down on the top of Nix Olympica, for example. Here is a case of a caldera just like this one, active in the only recent past, I would imagine.
But would you say, Ron, looking as we are now, round the caldera of Teide, we are looking at a small version of the scenes that may be found when explorers finally go to Mars?
I'm fairly sure, without the vegetation, without the blue sky, this is a typical solar system view.
Filming outside did pose a few problems for you, Patrick.
I'm sorry.
I had hat problems.
The hazards of filming, I think, Patrick.
You could say that.
Blast and hell.
Well, Mariner 9 was a great step forward. What you really want to do is to land and see what Mars is really like. And that brings us on to the Viking program.
Yes, landing on Mars is a bit of a nightmare. It's something that's challenged space agencies throughout the history of exploration. The Russians had some tries. They had one success, Mars 3. But
Not really a success.
Well, it lasted for 15 seconds on the surface, so we'll give them some credit.
Yes.
But it's the challenge of getting through Mars's thin atmosphere. It's not thick enough like the Earth's to allow you to brake on parachutes the way the Apollo astronauts did, but nor is it thin enough to allow you to just land with rockets like they do on the moon. It's a real problem, and the first to crack it, as you say, were the Vikings. But selecting a landing site for the two Viking craft proved difficult. They needed as flat an area as possible, clear of any possible hazard.
So let's begin by seeing what would happen if Viking came down in a permafrost area. You can see what would happen. It would certainly put the spacecraft completely out of action.
In the end, both Viking craft landed safely in July 1976.
Touchdown, we have touchdown.
We have, of course, landed on the surface of Mars and taken pictures both immediately after landing and again since then.
And the first pictures to come back were startling.
This is Mars. Incredible pictures sent back from Viking, showing a red, rock-strewn landscape under a pink sky. The detail is absolutely amazing, and these pictures would have seemed science fiction not so very many years ago. Let me now show you the very first picture ever received from the Martian surface itself. And there again we see the rock-strewn landscape, and I think we realize how incredibly fortunate it was, as well as skillful, that Viking came down safely. There we can see the landing pad, and we were discussing this in our last Sky at Night program, before Viking came down, when we were by no means sure whether the landing would be successful or not. Well, it has been. Viking is now standing in the plain of Clycie. It's working. It's sending back information at this moment. I was most impressed when looking at this superb panoramic view taken from the spacecraft, which I think is the most amazing picture sent back yet. Just look at the detail upon that. But now, coming into view, as well as part of the spacecraft, we can see things which look remarkably like sand dunes. And in fact, they look so like sand dunes, I don't really think they can be anything else. Wouldn't you agree on that, Geoffrey?
Indeed, those are beautiful sand dunes with the wind coming from the left across the picture, producing very nice streaking and sharp edges, quite characteristic of sand dunes.
Viking is now standing upon the Martian surface. It will not come back. It can never move again. All it can do is to send us back information. I think we've got to wait, quite a long time yet, before we have a probe which can go to Mars and bring back samples. That lies in the next decade or possibly the decade after that.
Well, that didn't happen. No sample and return probe quickly. It hasn't happened even yet. But don't forget the Viking orbiters. They went on going round and round Mars and sending back priceless data, particularly about those polar caps.
Yes, the orbiters are often overlooked, overshadowed by the landers, which get all the glamorous attention. But as you say, they looked closely, in particular, at the polar caps, these white areas that we'd seen wax and wane with the Martian seasons in the telescope. The question was, what kind of ice is this? What are the polar caps made of?
Was it thin layers of carbon dioxide ice? Was it a thick layer of carbon dioxide ice? Well, Viking told us.
Well, it's certainly strengthened my views because the most startling thing that's happened has been this northern polar cap, apparently the residual cap being composed of water vapour and not the carbon dioxide ice.
Well, this really is staggering. When you look at the North Polar Cap, well, it gives the impression of being water ice, and we now believe that that is precisely what it is, an ice cap.
And certainly the amount of water that's been found above the ice cap is about 20 times we find at the equator, and the surface temperature is probably about 20 or 30 degrees too high for CO2 ice to form. So we're quite sure that we're looking at a layer of water ice.
The fact that the polar caps really were water ice made the chances of life there decidedly brighter, and the experiments designed to find out.
That's right. The Viking landers made an audacious attempt to try and directly detect the signs of life at their landing sites. It was a long shot, and I'm not sure what people expected to find, but I'm sure they didn't expect the results they got. What they were looking for were the types of chemical reaction that you expect if you have very simple life in the soil. We're not talking aliens, we're not talking plants, we're talking bacteria. And they found some unusual chemical reactions. But on the other hand, what was missing was any of the building blocks of life, none of the complicated molecules we'd expect to see, no organics. And so we have this mysterious picture left at the end of the Viking mission where something unusual is happening in the Martian soil, but who knows what it is.
After Viking, there was a surprising hiatus. Probes were going elsewhere, and I think Mars was temporarily rather pushed into the background. And then, in 1997, back to Mars with Pathfinder and Sojourner. Pathfinder came down in July 1997 in the region of Ares Vallis, thought to be an old floodplain, which indeed it is, with rocks of various kinds. Pathfinder sent back pictures, and the little Sojourner rover crawled around inspecting and analysing the various rocks. And it sent back some amazing data.
The little Sojourner rover went around analysing with its X-ray instrument the chemistry of the surrounding rocks, and you can see in this vertical picture of the site, a composite picture, you can actually see a large boulder top right with the little Sojourner jammed up against it, sticking its little snout there, analysing that rock for its chemical components. And one of the first things that Sojourner showed to us was that on Mars we not only have basaltic lavas, like many that we have on the Earth, but also rocks called andesites, which are chemically rather different. And this was the first new piece of information that we got.
Pathfinder and Sojourner were the first of the new wave of Martian exploration. They were followed by Mars Global Surveyor, which went into orbit in September 1997 and lasted for almost a decade.
We have ignition and liftoff of a Delta II rocket carrying NASA on an Odyssey back to Mars.
It was quickly followed by Odyssey, which detected the signatures of large volumes of water ice under the soil, not just under the polar caps, but down towards the equator too.
And next, Mars Express.
Yes, this was the European mission, of course, most famous in the UK as Beagle's parent mission. Beagle, sadly, didn't make it down to the surface intact, or at least never told us if it did. But Mars Express has been a great success for all sorts of reasons. It discovered water again. It looked directly at the polar caps and confirmed there was water down there. But it also gives us the ability to see Mars in 3 dimensions. It has a stereo camera, so you can produce 3-dimensional maps of the surface, and we can go flying around the surface of some of the great valleys of Mars. And there's a stunning legacy from Mars Express, which is still working well.
To my mind, all these were equipped by those 2 splendid rovers, Spirit and Opportunity. Spirit was the first. It landed on Mars in 2004 in the crater Gusev, which is certainly an ancient lake.
Yes, and we know that because of the work that Spirit's done. These rovers were supposed to last for 90 days. That was the warranty, and yet they've both lasted more than 5 Earth years on the surface of the planet. It's an incredible achievement.
The rovers were designed to look for clues that would tell us what the environment was like. When we went into this, I never liked taking the attitude we're going there to try to find evidence of water. That's the wrong attitude to take.
That's not science.
Well, you know, Mars is what Mars is. I mean, our job was to go there and find out what Mars was like. And if it turned out that Mars had never had water at these 2 sites, well, so be it. Spirit landed successfully, got off the lander just fine, and everything worked, but we landed on lava. I still believe that there are sediments that were laid down in a lake in that crater, but a lot can happen in 3 or 4 billion years. And after the sediments were laid down, there were lavas that were deposited on top of them. And you know, that was what Spirit landed on. So we came looking for evidence of water, and all we were finding was volcanic rocks. Opportunity, on the other hand, rolled to a stop inside a little tiny 20-meter diameter impact crater. And we opened our eyes and we looked, and the very first thing that we saw 7 meters away in the wall of that crater was this spectacular outcrop of layered bedrock. And within just weeks, we drove over to it. We found out that it was largely made of sulfate salts. We found the ripples, evidence for water, all of that. I mean, it just all happened in 6 weeks. It was remarkable.
16, 17 months later, we're sitting here and the rovers are working well.
They're working extraordinarily well, yeah. I mean, the thing that we thought was going to kill them was dust on the solar arrays. Mars is a very dusty place. Dust is in the atmosphere. It settles out of the atmosphere. It coats everything. The day that Spirit landed, the solar arrays were putting out about 900 watt hours of power. That's enough power to run a 100-watt light bulb for 9 hours, okay? And as the dust built up, it went down and down and down and down and down. And we got down to about 350 watt hours. And we think the death is at about 250.
Okay,
so it was getting close to the end. It really was getting close to the end. And then one glorious day, we got hit by this gust of wind. I mean, it was just a blast of wind, nothing more than that. Cleaned off the solar arrays. As of like 2 days ago, Spirit was producing more solar power than the day we landed, because the wind has cleaned it off, and actually the sun is in a more favorable part of the sky right now.
You're coming back into Martian summer.
That's right. It's the middle of summertime. We got so much electrical power on Spirit right now, we have to shut her down for about an hour and a half or 2 hours every afternoon and take a nap just to keep from overheating.
Wow. When I next caught up with Steve, a year later, Opportunity had arrived at a breathtaking new site, Victoria Crater.
We spotted Victoria as a target the night that we landed. There was this monstrous crater, 800 meters in diameter. We had no idea how deep it was. It turns out it's like 75 meters deep. And I remember the night we landed joking about, boy, wouldn't it have been cool if we had landed there instead? Never thinking that we'd have a chance to drive that far. But after 21 months of struggling across the dunes and the drifts, we finally arrived at the rim of Victoria Crater, and the place is just spectacular.
And what sticks in my mind is this incredible image of Opportunity from above.
Ah, yes. Well, that was very special. This marvelous camera called HiRISE on the Mars Reconnaissance Orbiter spacecraft was turned on and operated really for just about the first time at Mars. The resolution of that camera is phenomenal. It's about 30 centimeters per pixel. So you could see the rover.
And you can see the rover tracks.
You can see the rover tracks, you can see the rover itself, you can see the high gain antenna on the rover deck. It's just phenomenal. And that image, it's hard to describe. You know, my reaction when I saw it was just, it was so good to see the rover again.
And if you thought that was impressive, Mars Reconnaissance Orbiter had another trick up its sleeve as it prepared for the arrival of NASA's next probe, Phoenix. Now, Phoenix was going to touch down in the Martian Arctic, but MRO managed to capture an image not of Phoenix on the surface, although we got that later, but of Phoenix on the way in. So this is the Phoenix probe hanging below its parachute as it's descending towards the surface of Mars, captured by MRO in orbit looking down on the scene. And I think this photo is one of the most stunning technological achievements that the space race and the space age have ever produced.
Oh, it must be. Now, Phoenix was different. It was not a rover, it was a lander. It came down, it stayed where it was, had various tasks, in particular looking for underground ice.
Each succeeding mission had got us closer to Martian water, but what we really wanted to do was sample it directly, and this was Phoenix's mission.
Touchdown signal detected.
By the time we got to Mission Control in Arizona, it had already been successful.
We're doing really well. We're meeting our goals. We're on track. And I'll tell you that one of the greatest thrills was looking back under the lander and seeing the thrusters had cleaned off the ice layer. I mean, that was what we were looking for. We were told there's ice from the orbiters. The theory says it's going to be down 5 centimeters. And we look underneath, and the thrusters had done our job for it. So there it was.
Even before you'd started digging, you knew there was ice there.
Before we started digging. We didn't have to dig an inch. And yet, we can't reach that ice because the struts and things under the lander prevent the arm from going under there. So it's there, but we can't touch it.
Oh, that's a steep back wall, isn't it?
Oh yeah.
And that really did go. That really did dig in at the front there.
When I returned to Mission Control a few months later, Phoenix was already feeling the chill of the harsh Arctic winter.
Temperature's been dropping. During the summer, the high temperature in the warmest part of day was maybe minus 20 degrees centigrade. Now it's down minus 30, minus 35, and the nights are getting very cold. It could be minus 100, 110, and it's headed down to minus 130. That'll be the temperature throughout the entire day in the winter, minus 130.
Just a few short months after that visit to Mission Control, Phoenix's life was over as it was encased in the winter ice cap. Like each of its predecessors, it had given us just one small piece of the Martian puzzle, and we certainly know much more now than we did in the days when the first spacecraft flew past the red planet. But the really big question remains unanswered. Is there life hiding somewhere on Mars?
Well, of course, Phoenix is still there, and also the other probe we sent to Mars. They'll stay there quite placidly. And in 50 years' time, what will have happened? Will there be bases on Mars? Will there be cricket on Mars? Time will tell.
On Mars, bowlers have to contend not just with the lower gravity, but with lower atmospheric pressure as well. It makes it really hard to get a swing on the ball, although it is travelling much faster when it reaches the batsman. The downside is that if the batsman connects with it, it's really easy for him to hit a six.
It's a fine shot for 4 runs and no mistake.
Good night.
Coming up next tonight here on BBC4, Reginald D. Hunter and Andy Hamilton are talking some sense into a couple more experts and reminding them that it's only a theory.
Flyby of the planet than it is to slow down and go into orbit. So the early probes just shot past and sent back what they could. And Mariner 4 saw some amazing things nonetheless. For example, it showed us the first real images of craters on the surface of Mars, something you couldn't see from Earth.
And then came those marvellous pictures from Mariner 6.
We've just had some amazing photographs sent back by the American probe to Mars, Mariner 6. Mariner 7, by the way, has been brought back under control, and we await news from that. But meanwhile, we have this superb series of close-ups from Mariner 6, and I'd like to show you those pictures now, beginning with Mars, as seen by Mariner, from a distance of more than 700,000 miles, which, of course, is a great deal further than the Moon is from the Earth. And even so, you can see there some of the dark areas, which may be vegetation, And at the bottom, you can see the white polar cap, which has always been thought to be due to some kind of icy or frosty deposit. And just look at that. Craters on Mars.
Good evening. We're going to go on a journey to Mars. Now, Mars is a world in some ways fairly similar to the Earth and always been of special interest, mainly, I think, because of the chance of finding life there. So, is there any life on Mars? We're still not sure. We're trying to find out. But meanwhile, just for a moment, cast your mind back to the 1950s. Science fiction enthusiasts had great fun with Mars then. Do you remember Quatermass?
You know, Rennie, when I was a boy, it was the great burning topic, were there really canals there and who made them? I remember my disappointment when somebody proved that Martians couldn't exist.
The funny word. Worn out before anything turned up to claim it. Martian.
Welcome now, Dr. Chris Lintott. Chris, I enjoy Quatermass immensely. Well, I know you didn't see it in the original, but you've seen it since. What do you think?
It's fantastic, isn't it? This vision of Mars as the place from which aliens come, which is right through 20th century sci-fi. Even though we knew that there weren't aliens on Mars, we'd come a long way from the 19th century view. Back then, observers with some quite large telescopes were drawing elaborate canal structures on the planet.
Plate of higher plants I brought along tonight. Two cacti. This cactus has been quite healthily growing under Earth conditions, and you see it's quite a nice, firm-looking sort of cactus. This one here has spent one night under Martian conditions, and I think you can see without any doubt that it's got a distinctly morning-after appearance.
Well, despite the lack of aliens, it's become very clear that Mars is a fascinating world. But of course, it never comes much closer than 35 million miles, so we were bound to be limited. The best way was to use space probes, and the first space probe went up in the early 1960s, both Russian and American. But the first real success came with America's Mariner 4 in 1965.
Yes, and like all the early probes, this just gave us a fleeting glimpse of Mars as it shot past. It's much easier to do a flying. These were the products of technologically advanced civilizations.
Pure trick to the eye. But of course there are dark patches on Mars, one thought to be seas, and then thought to be tracts of low-type vegetation. But of course you've got to remember, on Mars, the air is very thin indeed, what we normally call a vacuum, and it's also dry, and there's no water. There's ice, but no water.
So the question going into the space age was whether vegetation could survive on Mars. And I know the sky at night demonstrated pretty quickly what would happen if you tried to plant things there.
We did. We took two cacti. One we kept under Earth conditions, and the other we subjected to what we thought were Martian conditions. And this is what happened.
Well, it's rather unlikely, I think, that any of our higher terrestrial plants would survive under Martian conditions, although it's just possible that some very lowly forms, which we've not yet tested, may. But just to show you the